is how you do the core practical about investigating specific heat capacity if you're doing physics IGCSE for the Edexcel course. This is quite a good website, so advertising for Save My Exams. I hope they don't mind me recording their experiment. So the aim of the experiment, it says, is to determine the specific heat capacity of a solid and of water by measuring the energy required to increase the temperature of a known amount by 1 degree. So normally specific heat capacity means how much energy does it take in joules. So usually electrical energy is supplied to a heater to increase the temperature of 1 kilogram, for specific means per kilogram, by 1 degree Celsius. Okay, so basically we put a heater on and we measure how long the heater is on for. So that's your independent variable, is the time that the heater is on for. And the temperature will increase as you energize the solid. So we have to have a power supply. So normally we would keep the voltage constant for the power supply. Okay, the other equipment you would need would be a thermometer to measure the temperature change of the solid or water. Now, when I did it with my class, I used a kettle and some water to show them that's what happens when you boil a kettle to make a cup of tea or coffee. And you could use a solid block of aluminium, which are standard equipment in most schools, and it has a place for the immersion heater to go in, so you're going to use an immersion heater to heat the solid or the water. And the immersion heater fits in perfectly in the cylindrical hole which is in the aluminium block. So to either you can use the aluminium block, we've also got copper in that can be used in our school, or you can just use a specific amount of water. And remember that every milliliter is 1 centimeter cubed, and that's 1 gram per centimeter cubed. Having just done the topic on density, you should know that. So we need the voltmeter to check the voltage of the supply, going to the immersion heater, the ammeter as well, and if you multiply the voltage by the current, you get the power that you're using, and power is the rate of transfer of energy, and as you know, you're increasing the time. So once you know the voltage, the current, and the time, you can work out exactly how many joules of electrical energy have been transferred to the solid or the water in this case, if that's what you choose to do it with. So you'll have an electrical power supply. 12-volt power pack will probably be the normal thing to use to power the immersion heater, and the digital balance to be able to measure the mass of the material that you're investigating, and of course a stopwatch so you can measure how long it takes. Okay. Resolution is the smallest interval that you can measure on each of the instruments, and these are suitable resolution that are suggested for the equipment that you would probably have in most schools. Okay, so here's the diagram of the method to set it up. So that's all the equipment you need. There's your power supply. It says 13.5 volts, and that's going to the ammeter, and then from the ammeter you can see it goes to the immersion heater, and then from the immersion heater it should go back. Let's see which one it is. It should go back to the power supply. Not easy to see where it goes. There it is, this one. It goes back to the power supply. So the ammeter, immersion heater, and the power supply are in series, and then the voltmeter is added in parallel to, in this case, the immersion heater, but to see how much voltage it's using. Okay, over here you'll notice that the immersion heater is not fully submerged in the water, so some of the heat is escaping into the surroundings. Okay, and the thermometer, you want to make sure you're stirring the water when you're doing this to make sure that the temperature of the water is constant throughout or the same throughout. You don't want the bulb of the thermometer touching the glass bottom, okay? Ideally also, you don't want that, the heater also is heating the glass. So that's another inaccuracy, that a systematic problem that you may have if this is how the experiment is carried out. And then of course you've got the digital balance to measure the mass of water that you've used, okay? And you can do the same by having, instead of the water, an aluminium block within which this immersion heater fits exactly. There's a hole for it, and there's also a hole designed to be the size of the thermometer, okay? So this is the method, so you can stop the video and look at the method. It might be worth you copying this out for your own notes. And they've suggested the power supply is set at approximately 10 volts when you start the experiment. So the methods are given and you just got to follow it. And so you're recording the voltage and the current as you are doing every 60 seconds, and they're suggesting doing it for 10 minutes. The initial temperature needs to be measured, obviously, so you know how much the temperature increase is going to be, because that will be in the formula. So the energy supplied, as I told you before, is the voltage in volts multiplied by the current in amps times the time in seconds. So that's how much electrical energy has been transferred. So it's electrical work, if you like, okay, to the water in this case. And then, so this is what they're telling you is the equation for energy transfer to it, okay? And then as you increase the energy, eventually the temperature will start going up at a constant rate, yeah? And you'll be able to, the gradient of this straight line portion is what you want to determine for the specific heat capacity, because if you remember the formula for specific heat capacity, it's the ratio of energy to temperature rise, yeah? But you also need to take into consideration the mass that you've used. I think they were using 400 grams, 400 milliliters, that's 400 grams. So it depends. If you use the aluminium blocks, they're exactly 1.000 kilograms, so they're known quite accurately, okay? Then it says you need to use the specific heat capacity equation to calculate the specific capacity of the material, yeah? And they haven't given you the equation here, so you'll need to remember what that is. Let's see if they come back in. And here's some uncertainties or errors that could come up. So evaluating the experiment afterwards. Systematic errors are things which are always causing the same direction problem. So you ensure, for example, the digital balance is set to 0, so it doesn't give you a false reading always. For example, if it wasn't set to 0, it would give you the wrong reading always in the same direction. Okay, some water may be lost by evaporation, it says, so that's another systematic error. So the mass will change, yeah, so that's something to consider. You can stop the video again and look at these errors that could be brought into the experiment, and this could be questions that you're asked about in an exam question. And then it says, remember to take only the gradient on the straight line region. Before this point, it says the energy supplied is being used to heat the immersion heater itself. That's why it doesn't go straight line initially. So you need to kind of reach thermal equilibrium for the heater before it can then pass it on. And the other thing I always tell people is once the time that you've chosen to use is finished, wait until the temperature stops rising, and that will be your final temperature reading, because there is also a time delay for the heat to get to the thermometer, okay? And then there are random errors. Random errors are things that can be either too high or too low. So it says stirring the water constantly will ensure the temperature measured is the temperature throughout the fluid. If you don't stir it, then it could be either too high or too low, depending on where you've placed the thermometer, how close it is to the heater. And then it says when the current or voltage values appear to be changing between the two values next to one another, this could be lead to inconsistent results. So you need to choose the higher value it suggests as a way of ensuring you're doing it systematically. Okay, safety considerations are other things that you can consider or should consider. So there's danger obviously because the immersion heater will get very hot. It's a good idea to have a heat-proof mat to place it on after you finish, so they've mentioned that. And we're using direct current supply, so that could be a danger in itself. The beaker may become unstable with an immersion heater and a thermometer resting in it, so be careful. It could also lead to breakages. Okay. Goggles are always recommended when you're doing something where the water could splash, for example. And always, as I've taught younger students, make sure you stand up during the whole experiment. So this is the final experiment for the topic that you are currently studying, which is solids, liquids and gases. So I hope you found that useful. Please give it a like if you found the video helpful, and share it with your friends so they can have a look at it, especially if you haven't taken your topic test or if you're revising for the mock exams. So there's the graph you need to use, and there's a table you need to have, and there's the equipment that could be used either for water or for an aluminum block. Okay, so thanks for watching, and if you want to know when the next video is going to be ready, please make sure you've subscribed and you'll be notified when another video is uploaded. Bye for now.